Example 1b, we are going to write an equation of a hyperbola centered at the origin with vertices 0 plus or minus 4 and foci 0 plus or minus 6, and then sketch. So first of all, let's sketch what we have, and we can add to our graph as we go. So I know that my vertices are at 0 plus or minus 4. And that my foci are at 0 plus or minus 6. So because my hyperbola has all of these major points on the y-axis, that tells me that my hyperbola is going up and down. So my equation is going to be in the form y squared over something minus x squared equals 1. And that first number is going to tell us where our vertex is. So we know in this case that our vertices are at 0, 4. That means I have to have y squared over 16 because this is what our vertex is squared. Okay, vertex squared gives us our a squared here. We have to figure out what goes underneath x squared, and that's the other dimension of our central rectangle, which we don't know. But what I do know is that I have a right triangle somewhere, wherever this end of my central rectangle is. Okay, so I'm just going to put it over here for now, okay? I don't know where that central rectangle is actually going to go out to. But this is what my right triangle is going to look like. Okay, so I go from my vertex to the origin out to wherever our central rectangle is, whatever that endpoint is. And if we draw in our right triangle, I know this length is going to be 4. I don't know this length. The hypotenuse of my right triangle is from the origin out to my focus, and that length is 6. Okay, so let's use our Pythagorean theorem. X squared plus 4 squared equals 6 squared. So that's x squared plus 16 is 36. X squared is 20. Square root both sides. We'll get the square root of 20, and that radical can simplify to plus or minus 2 square root of 5. And again, I'm not going to be too picky with how you have your radicals simplified. So 2 square root of 5 is where, how far out that central rectangle is going to go here. Okay, so we go out to that 2 square root of 5, which is just over 4. It's actually pretty close to how I had this drawn in. Go out to 4, a little over. And keep in mind that that central rectangle is important because those diagonals give us the asymptotes for our hyperbola. And that lets us draw in our hyperbola the rest of the way, finishing off our sketch. And our last thing that we have to do is to finish off our equation. And to finish off our equation, well, let's look back here. We knew that other dimension for our central rectangle was 2 square root of 5. Right before we simplified that square root, though, is the square root of 20. This is probably easier to look at when we figure out what number goes here. Square root of 20 squared is 20, and that gives us the rest of our equation. Y squared over 16 minus x squared over 20 equals 1.